Good day. It's January 27th, 2024. Hello, gentle readers. Welcome to another episode from a desk of Ross Finlayson of Moments and Motion. Geometry is motion. Watching these sorts of videos is, on the one hand, sort of a linear narrative, meaning they were recorded in an order and they, as they develop and introduce definitions and concepts and derivations, it so follows that it makes a linear narrative, meaning once terms are introduced and their dialogue represented and their dialectic established and their discourses sort of maintained and established, derived, then over time it becomes a cumulative set of definition. So at the same time as that it's an individual's linear narrative and development and sort of a curriculum, it's not for anybody else, meaning that there's all this sorts of individuals have, of course, their own conceptions of mathematical objects, the objects of theory, foundations, and all these kinds of things. So at the same time, it's sort of a cumulative linear narrative. Then it's hoped that each one will kind of have that it's the same from any starting point. That because it's a coherent narrative from kind of a single origin, then in that manner, any one of them is cumulative in the context that there is a context. So, insofar as going from one establishment of concepts to another and this kind of thing, that it's coherent. And so this, I hope, will be useful. And when trying to approach something like a theory of theories or foundations or this or that, the study, a theory, then that's one reason why when trying to figure out unified foundations, it's kind of good to have a unified, univocal type of outlook for it. So in this sense, I've kind of been lucky because for a long time I've been able to kind of collect these derivations and definitions and have already gone to the trouble of establishing kind of their common milieu of one continuous thing. And then I just point back to the giants of our canon and to these touchstones of the concepts, because that results in one context and one thing. So if it's like one time Isaac Newton said, is like, if I've been able to see farther than those before, it's because I was standing on the shoulders of giants. The goal here is to hold the stack of giants up, to get underneath that, to get the foundations, and find the foundations that holds all the giants up. So basically that means something that arrives at geometry and something that arrives at logic. And so then the idea that there are many different approaches to all these things, yet they still all together form a common milieu. It's like Platonism. And the theory. A theory is the theory. That there is one at all is not the one anybody has, but the one we all kind of sort of attain to as perfection and ideal. So it's just recognized that everybody lives in the human condition, and it's a wonderful place to be, and that there's all the mystery of perception and being, and the questions of philosophy, and kind of pointing back to why is there something rather than nothing, the fundamental question of metaphysics. Then as for it doesn't really take too much to have quite thorough unified approach to mathematics and logic. And then it's also kind of so that physics and science is sort of a unified thing, and that it doesn't take very much to have it so that there is a very, very common context for all the logical things. Platonism, that's usually called. So on Moment in Motion Day, what I thought to do is, most of the talks about moment in motion have been kind of about the wave theory of motion, with that being considered for this attenuative and dissipative and constitutive, reconstitutive, and oscillative and restitutive, for the tendencies and propensities for rest and motion, for the definitions of change, and the entire higher order apparatus of that the slightest push causes a linear impulse, while at the same time it starts as 0 and goes to 1. All these notions of the continuum mechanics that go into this has that waves are considered pretty much the milieu for those kinds of things. And it's as of that waves are models of change in an open system. And thus that for the linear impulse, which is how everything is called classical, and it's like all the formulas line up, and you can draw it, and you can chart it, and it results in the diagram A connecting B. That it's all in this theory of the sigma or sum potentials, the potency, the dunamis, that according to this principles of least action, fundamental principles of least action in inverse, kind of logically, it's so. And that what is, and what will be, and que sera, sera, and the past is history, and the future is not yet written. So there's a clock hypothesis. Is the same for everybody. It's and insofar as a theory can be fair at all, it's like there's nothing more to be said about it. It's the same for everybody. So this is kind of what I found most fulfilling in theory, generally, basically. Well, all right then, let's take a look at these books and what we find here. Been reading about Galileo. We've mostly been reading about Galileo. I've been reading De Santillana's 1954 edition, a reprint about the time of Galileo, about 1600 to 1620, and Bellarmino, and the surrounds, Urban 8, and these kinds of things. And when the science became basically the worldly study. So that made me happy, because we kind of look at it as sort of like, well, Galileo was punished for being Copernican when it was not dogma, or according to the Council of Trent. But it also reflects the change that happened right in that time and the reform of that. Well, at the same time, there was Counter-Reformation in terms of, the balance of power and these kinds of things. That at the same time, it was an enlightening time. When we say enlightenment, we generally mean enlightenment to to reason and rationality and these kinds of things. Fast forward 200 years, 300 years to 1920. Then there was like the recurrence of existentialism and this and that, because strong logical positivism had definitely shoved off from teleology, or the notion of that there's a cause of things, and the whole idea of first principles and final cause. So that then had a void filled by existentialism and nihilism as those kinds of things. And then with regards to today, that 100 years after that, that's kind of quite de rigueur and considered classical quasi-modal logic as what most people use for their syllogistic reasoning, as long as it's not wrong, where it's one of those things where, according to the computer program of these kinds of things, that it is mechanical in its inference and reasoning, so it's just subject to the limits of its definitions and the thoroughness of them being carried out. So with that kind of thing, then let's take a look at some of these books. So first, I thought I'd clear off this stack a little bit. Astronomy and the imagination. This is really great because the guy kind of helps to explain why when you look up at the sky, the objects are smaller. When they're horizon, they look bigger, and it's just not an optical illusion, but an effect. This is about how to fit things. This is, of course, the topology via logic, and so it gets into part of our continuum mechanics that this is from the 50s, 60s, and 70s, and so it's important because they kind of built our standard Cauchy, Dedekind, Weierstrass standard real analysis and the topology, what follows for continuous domains, at least one of them. So we at least have one, it's called standard. And then these other ones coming in, this is a great book for that. It's constructively in its account builds one of these things. And this is the guy about blast power and ballistics, concepts of force and energy in the ancient world. And it details the metalwork, circe, the circle or circler, and the potter's wheel. Homer, in his simile for the maze dance, speaks of the potter sitting by his wheel. And so it describes how technology kind of developed with the theories vis-a-vis the belief systems and the symbologies in an odd transcendental form. We have here the Greek idea of the physical universe by its very nature, ensuring an ultimate balance in its moving and changing ingredients. About the Middle Kingdom of the Pyramid and the Egyptians. Plato and the Republic. Treating the professional training of artisans, says no one can become a skilled dice player if he plays only for pleasure and hasn't devoted himself to it. Anaxagoras, he compressed air in wineskins, says Aristotle, and showed that it offered resistance when the skins were stretched, but he rejected the theory of pores and held to a belief in continuity. Aristotle himself sees present in matter a kind of dynamis, as if it were a channel. So this is with his tendencies and propensities. His term for channel is aulos, tube pipe, which we saw with pre-steer. If the form is no longer able to function, it will cause a diminution of the quantity, though the form persists. It thus helped inquirers to form ideas of systems pervading the body, such as veins and nerves. He talks about capillarity, the effect of surface tension, that according to capillary action, that it will be so satisfied that capillary action is as of a course of the dynamics of the universal solvent. Heraclitus. Some copyists have tried to extend the image by writing ithmoio for ethmoio, so that around the opening of the gurgling strainer becomes above the pass of the isthmus of ill repute. Well, he says, at times an examination of language reveals a complex tension between mechanical and organic or social ideas. Well, there's a context to things. The act of swinging things around at the end of a cord also helped in building the idea of circular movement. So this is one of the most usual sorts of experiments after all, is centrifugal force. You take a bucket of water. Everybody knows what comes up must go down, and then water fills its container. And then if you tip over a container of water, it flows out. But if you spin it around, it maintains, according to the central moment, establishing its fixture. Then we get into whether it's centripetal action or centrifugal action. So everybody learned it's called centrifugal force. And then later in the theory, it was kind of like, well, we actually have to call it centripetal force because the way we define the arrow or the direction of which is real and classical and which is real and potential is either way. And so then the idea is that yes, the centrifugal force is still a thing, but it implies also this broader context of the surrounds and the theory of the sum potentials. So that's been about the same since Aristotle tells us. Others agree with Empedocles that it is the excessive swiftness of the motion of the heavens as it swings around in a circle which prevents motion on the earth's part. They compare it to water in a cup, which when the cup is swung around in a circle is in fact stopped from falling by the same cause, that often finds itself underneath the bronze, and it is its nature to move downwards. No doubt the same sort of image lies behind Anaxagoras' idea of the centrifugal force in his cosmogony. With the earth as center, the sun, moon, and all the stars are flaming stones which are carried around by the revolution of the ether. The swinging of a sling must also have contributed to these ideas. Cicero cites Chrysippus as noting that the cylinder and spinning top cannot start moving till given an impulse, then the cylinder goes on rolling and the top spinning according to its nature. So this is that it has its own rotating frame, and rotation is free in its independent frames. So when we look back to reading from Einstein, this is his dika. Aulus Gellius makes the same point about a cylinder set off rolling down a steep bit of ground. He talks about the lathe, the tornos, to turn with the lathe. On the cosmos, discussing the universe as a single, continuously moving sphere, remarks, on the cosmos. But there are necessarily 2 points which are unmoved, opposite one another, just as in the case of a ball being turned in a lathe. They stay fixed, holding the sphere in position, and the whole mass revolves in a circle around them. These points are called poles, the poloi. The straight line joining the poles is the axon, axle. So this is quite most familiar with everything from polar analysis and the axes of our Cartesian coordinate setting of the Euclidean with an origin, and all such matters of the centroid and of rotating frames in relativity. Poloi are the poles, and an axon is axle. So it's got a singular axle and opposite poles. How old the lathe was cannot be determined, but by Aristophanes' day it was sufficiently familiar for its action to be used figuratively. He speaks of neatly turned verses. So inverse, of course, is a very usual quantity of axiom in any kind of theory, because it's just looking at things thoroughly from either directive. Is it so? Is its inverse so? Is its affirmation so? Is its negation so? Inverse. And then with regards to the singularity and multiplicity theory, it's like the openness or the crisis or the perestroika or the opening or the singularity or the multiplicity is just as after generalized inverses, vis-a-vis the usual principle of least action, and what goes up must come down. Same kind of thing. It is an inverse in effect. Theophrastos referred to evaporation to explain Thales' assumption that all is water. From Anaximandros on, every philosopher of significance made a large and increasing use of the phenomenon for his explanation of the cosmos. So attenuation and dissipation. From the writings that have come down to us, we can often make out how scientific ideas have arisen in the minds of the Greeks. Well, this is projection. Psychological projection in anthropomorphism, for example, is like assigning a reasoning apparatus to anything. And so here it's as for this study of the Greeks, and it's also enshrouded in our canon. So it's kind of like the much later German and continental philosophers of the Western canon make for a reading of our much older Western aspects of the philosophical canon. We're viewing it through their lens, and so we can never really see it as they do, or really know what were their motives, what were their thinkings. But this is for matters of language and common context, and as to why what the author has, we can often make out how scientific ideas have arisen. Some ideas are closely linked with social experiences, others spring from their direct observation of nature. So when I found this, I thought it was really a pretty great book because first of all, it has this whole kind of romantic association with things that go boom, and secondly, it talks about the theories of force and the classical theories, which include these super classical notions. These ancient thinkers were very thorough. They didn't have a ring cyclotron or a tevatron trying to make a Higgs boson, but they did have the sky survey, and they did have the laboratory of the terrestrial frame setting, and they did have all such matters of thought experiment that even to this day they're considered the classical expositions. Socrates states that he has been told that this dia aeon, through thing or force, is to dika aeon, justice, and also Zeus, since all things happen dia it. Dia meaning both through and Zeus in the accusative. Beyond the point, he adds, there's no agreement. One person says the traversing force is the sun, but another mocks at him, asking there can be no dika aeon after sunset, declaring that the force is fire. Heraclitus declared, how can one hide anything from that which never sets? Plato clearly took that which never sets to be fire. So that's just a general notion of it was like change and state. Fire and water. And those are like the sublime quantities, and earth and air are the ground, or the alea, and air is that those two together are the fundament and firmament. So it's just a simple sort of dialectic that results all the sorts kind of notions, and then their assignment in the models, when that's all there is, a conflation to any other thing. So the idea is to figure out how this dually void and universal, dually self-infer-consistent, dialetheic, that which is disclosed, revealed, becomes the truth or verity, because it is. For Heraclitus, Sophia to Sophon, or wisdom, still has a craft note about it, expresses the know-how. So this we'd call the ontological vis-a-vis the teleological. And then their prime mover, or si epi muove, was just the demiurge, basically. Psyche. There can be no doubt that psyche belongs to the same group as pneuma, spiritus, and anima. Anaximenes certainly saw it as a form of air. So, this is as of the reflections of their ontology vis-a-vis their theories of teleology. Anaximandros, who is mainly concerned with his physical aspects, though his statement, psyche rules us, suggests intellectual powers as well as vital essence. So in that sense, I'd relate that to the object sense for Kant's sublime, and Hegel's maintenance of the bridge between the teleological and the ontological for an object sense, a number sense, and a word sense as an available sense, so that in all of the collected argument and rhetoric about why everything has to be phenomenal and phenomenological, it's included, so that our mathematics has one, and it has real infinity, but a real infinity. And that is always only the real aspects of what is the truly infinite, mathematically. That's so equipping the theory that way automatically equips the rest of the narrative with this richer, what's called non-standard or non-Archimedean, but is actually just super standard or super Archimedean, the extraordinary, not the apeiron that is absurd, although absurdity has a great place in most things, and it's a key touchstone and framing of all such matters of conjecture and imagination and thought and deliberate ponderance at all. But that there's a real continuum, then that is what then drives this whole idea again, the axiomist natural deduction, being able to arrive at it all from nothing at all, because it's everything at nothing at all. This is really kind of a personal course for anybody to adopt for themselves. a theory. Here it's a study in technical philosophy and foundations for formal mathematics and the rigor of mathematical logic and the ubiquitous success of mathematical logic and natural sciences, what so follow. In a world with the objective human condition, where statistical inference is very, very, very quite natural, and then things like the particle wave duality and why they have a stochastic or probabilistic statistical interpretation. It be in our classical milieu is getting back to why that's really just after discretization, after quantization, which is taking the continuous of these waves and making them measurable quantity, the value, a linear thing, classical in the middle, the mesoscale, about why these super classical models then just kind of re-equip that whole context back into a universe in the time, as Einstein puts it, the time. So I enjoyed that book quite a bit, and it would go well with like Farrington's book, or it's a survey, and it gets into all such matters of like the ballistae and the trebuchet and a bunch of different kinds of things. Yeah. So then what we have here is Parmenides again. See, this is from through the lens of Heidegger, his lens of the Greeks, and then if we were to consult him, he says recapitulation. So summary, putting it back together. That's basically what it is. It's recapitulation. The essence of truth as opposed to concealedness, according to the first two directives, unconcealedness and unconcealedness. See, I'm not quite sure. He's just got the emphasis on the two sides of it. So he says the essence of truth as opposed to concealedness, according to the first two directives, unconcealedness and unconcealedness. So you see that it's not necessarily like a binary proposition, and with regards to the state and change of things, it's just so for establishing, this is kind of something. We ordinarily translate the goddess truth, Aletheia. This goddess treats the thinker upon his arrival. What the essence, truth. Therefore, prior to the formal clarification of the individual fragments and verses, we must attempt to illuminate the essence of truth. This is that it's just a theory of truth. So deal with it, work it up. It all has to make sense together. Word forms, Wörter, literally, Wörtlich. Ratio is a facultas animi, a power of the human mind, the actus of which inhabits the inner man. The res, the thing, lies apart from ratio. So this is reason and rationality as flip sides of a coin, and both together are they always go together for each other, and that's really what our rational reason is, and our reasoned rationality. In rectitudo as adequatio, linearity is adequate. Ratio is supposed to assimilate the things. Now, what is completely lacking here is the essential space of aletheia, the unconcealedness of things in the disclosing comportment of man, space completely covered over by debris and forgotten. So we call this wallpapering or coding. The essence of truth as veritas and rectitudo is without space and without ground. No, that's the whole idea of this kind of a theory is that there is this thing. Not that we know it, because we're not infinite omnipotent beings, but it is what it is. A question was thus bound to arise as regards truth. How is it at all possible for an inner process of the mind or soul to be brought in agreement with the things out there? And so begins the various attempts to explain it, all within an unclarified sphere. So, Heidegger's writings are voluminous, and they reflect his ponderances of these things. And then he talks about the animal rationale, about how we're, as people, when I say man, it's generally intended to mean neutral in the usual sense of gender, but that man is machine and animal, with animal basically being the instinctual and machine basically being the mechanical. But man is mind, and so mind is what separates us from machine and separates us from animal. The essence of truth is determined on the basis of this assurance and certitude. The true becomes the assured and certain. The verum becomes the certum. So that gets into a lot of the ideas about what is validated and what is furthermore certified. And meaning it's like, it just means validated in a wider context. So it's never complete in that usual sense, because it just means validated and validated and validated again in an expanding sphere of the things vis-a-vis verity, truth, this verum and certum. So these days that's a real big deal, because you want things to be certified in the usual sense, so that then you can say they're generally validated. And then this is the way that then you can trust them. So it's just subject to all the limits and weaknesses of its reason and inference, and it's about what objects it can so detail and whether they're closed or open. So physics is an open system, so we have a generally thorough theory about the whole thing. And then with regards to all such matters of all the data of science about how it's, made to be kept together as a fundamental theory, which is so spectacularly successful and explains why airplanes fly and the cats fill the feed through the internet tube, or whatever you might want to see as some kind of success with technology. That it is, though, that these particular quantities of thinkings, which result judgments and decisions vis-a-vis compromise, are to be considered with regards to that. There's much to be made for the establishment of the reasons of why there are or aren't logical paradox, or are or aren't closures or these openings, that it's so relevant to make it so that there's not false verum or false certum. Type 1 and type 2 errors basically being false positives and false negatives. So let's see, that's the stack of books. Then here's Johannes Kepler. So this is just kind of going back a few episodes of what books we were looking at here. Kepler is pretty great. He's lots of fun. Kepler is pretty great about things, and he really kind of knows what's going on. So let's see here. Setting the clock makes for so that the monotone meter of the ticking of the clock helps remind that there's a sort of monotone in a metronome. The metronome is a device familiar to most people, and I'm not quite sure what necessarily there may be of those today digitally, because you got a crystal clock apparatus, and basically according to a well-regulated source of electrical current, it will drive a clock chip at a particularly well-known and regulated fixed frequency, and so you can set the beats per minute is generally the usual idea of the metronome. And then the implementation I was familiar with is in accordance with the pendulum, and so it is a precisely manufactured stick, or the piece that has an axis through which it can swing, the pendulum. And then the weight of the pendulum is in accordance to a gradated scale, which is so defined that by adjusting the distance of the weight from the axis and then starting the metronome, that the metronome will continue, and its dissipation is very, very low. So for quite a long time, the metronome will keep time. And in this manner, it will keep time according to the modularity of it. And it's designed that is defined that in the terrestrial frame, it's simply so that as a matter of the local value of the constant g, which is familiar to people as kind of like 9.2 meters per second squared, or the force of gravity around the world. And it varies in the last two digits according to what's called the geodetic survey around the world, so that a given metronome is accurate to a couple decimal places, and that otherwise you'd want a reference timing that wouldn't be so, as a consequence that the timekeeping apparatus was according to its place in the potential well of Earth's acceleration. But anyways, the metronome is a real great thing. And I remember being fascinated as a kid. It's like we had a piano or something like that, and for some time, and then the only thing that came with it was a metronome, and so it was shaped kind of like a little pyramidal box, and then so the front cover came off the box to expose the metronome, and then it was adjustable as to like so, and then you just set it ticking, and for quite some time it will tick. It was a high precision instrument, designed via its empirical relation to make it so that according to a given fixed constant reference timekeeping, that it resulted a faster or slower or at any one time. Because once you start the metronome, you can't adjust it. It just kind of, you have to stop it to adjust it. So it's kind of like the classical constructions of the edge and compass or something like that. It's like, well, every time you use a compass, it closes, so you have to start all over again every time. It's strict classical rules. It is so with the metronome. And with regards to that being, because it's mechanical and you can interact with it, it's something that I would hope that everyone would have the experience to have. If there was another thing that's kind of related to that, it's the tuning fork. So the tuning fork basically has that it's a piece of metal, and what it is, it's a piece of metal of some particular properties of it, and it's a particular shape, and it's a particular size, so that resonance is what results when you apply it, like by giving a thump, as with a tuning fork hammer, or just banging on the piano or something like that. Then in its frame and in its shape, it would resonate at this frequency. So while is it once radiating the sound, it for a while it's able to hold that level for a while. So it's not until when it attenuates and finally drops off, until then it's continuously radiating at this constant rate of sound. So it's kind of like the metronome, the tuning fork. And then what it is, it has a little foot, so then you can take the foot and then put it on the frame, like of a resonating frame, like the piano or something like that. Piano, pianissimo forte, the piano. And then the sound through that will echo on out. So you hear this tune to A or C, the usual tunings of the tuning forks. And I prefer the C tuning. I hear it better than the A tuning. Some people hear better the A tuning, but I hear better the C tuning. And thusly, it's just an example exactly, kind of like when there was a discussion before about how musical stringed instruments were able to be designed off a diagram and schematic without regards to trial and error or the interactive of tuning the thing. That these tuning forks and the metronome are so similar, that according to a theory and some constants associated with the empirical, that then it results that they can be related in so few words and according to a theory and so few formulas, according to a schema, work as information of knowledge and the application of knowledge. So that amused me. I haven't thought of that in a long time. The metronome and the tuning fork. And these days for something like the guitar, where it's kind of like, well, I have pitch pipe, which is various reeds that establish each of the tunes for each of the strings, in the usual 6-string guitars tuning, or as with regards to, they also have like digital tuners that basically just kind of fit on the end, and red light, green light, these kinds of things. But I tend not to really know that very well, because I although I can hear relations in tones very well, I don't have perfect pitch. I don't really believe in perfect pitch or pure tones. I always hear overtone. So that's just one of those things. That then, with regards to tuning the guitar, is that the strings happen to be that they're close enough that you can, that one particular fret is associated with the next strings, and they just sound the same. So as long as they sound the same, and then intonation is like up 12 frets from that, as long as that sounds the same, then the tones are relatively the same. Where the intonation is that the octave of the tones is that the relation of the notes are the same in the lower octave, and the relation of the notes are the same in the higher octave, according to the harmonics, the Laplacians, and all the theory as we've got into quite a bit in the discussion of the harmonicity and all this kind of stuff, and fundamental tones, those being kind of like these classical spectroscopic lines, or what results after discretization and quantization. And then this resonance theory above wave theory, that it's possible to so briefly then relay how things like wave theory and resonance theory have very practical and demonstrable applications in effect. And it's then possible that it's not necessarily, again, to have either a great grand laboratory nor a great grand library, that it is possible to have, so briefly, a musical laboratory and demonstrate these known things. Then that for any scientist or anybody who cares to reproduce the experiment and measure its observables and observe if there's a matter of falsifiability to these expectations, those are important enrichments to universal education. Right. At some point in time, having the piano was I think it was replaced by a stereo. Waves and layer media. So we're in here somewhere. And then, so this is our course here, waves and layered media, moments in motion. This is the turbulence symposium. I should make a bookmark for this. So we've got structure functions. The undifferentiated velocity of signals were also recorded during the observational period. A calculation of structure functions from these signals permits the values of skew, and the coefficient of excess of the derivative to be put into a broader context. There are also some interest in themselves. Taylor's hypothesis was assumed in computing the 2-point downstream velocity differences. The normalized third-order structure function, skewness. The normalized fourth-order structure function, flatness factor. So these get into determinants, discriminants, factors, indicators, what can be computed. The excess of small values is not unexpected due to the nature of this distribution, vis-a-vis the central limit theorem. Figure 7 is an example of a theoretical logarithmic normal. We were talking about the log normal distribution after the central limit theorem, vis-a-vis a uniformization limit theorem, and what it means to combine these out into the hyperbolic, combining the central limit theorem and the long tail. The distribution shows small values of the probability in the neighborhood of 0 and large values of probability for very nearby values. Oh, so this is really great because what it shows is it's got the dip in the middle. So this is the one where you expect when things have a tendency towards the mean, towards the average, that's where things will add up. But this is a great little example of the two-sided probability density function for a logarithmic normally distributed variable. And so that's an example of one of these things that otherwise is true in the limit, but actually in infinity or when it reaches its state, it goes to 0. It belies its finite inputs and arrives at 0. And so it's really kind of a thing then to figure out. It's like for asymptotic freedom is the idea is like, well, strong nuclear force gets stronger and stronger, 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 what holds together the nucleus of an atom till the middle it's loose. It's asymptotically free. Because in this model it's pointing all the way from the outside of the universe to get to there, to keep that just direct in the theory of some potentials. So this is kind of example, and then another one is the Higgs boson. So the Higgs boson, they're like, we're looking for a peak. We're looking for a peak. As long as we can find that peak, we'll have justified our billions of dollars spent on this Tivotron. They're like, well, we found the peak. And it's like, great, well, you got at the peak to the guru. What does he say? It's like, well, the guru's down in the middle of this well, way at the bottom of the peak. But he's looking up. He says he can see the stars. This was a factoid that if you dig a very, 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 very deep well, that optically it acts kind of like a telescope. And so that the usual light that occludes being able to see the stars during the day has that from the bottom of a deep well, you can see the sky and you can see the stars in the sky, even during the day. So these kinds of things, this helps relay one of these primary notions of the superclassical analysis. Because inference of the inductive or forward sort reaches an impasse, or here that it falls off. And so then trying to figure out, basically it's building as a matter of reflection, this or that, and then that in the center of this distribution, it's kind of like, well, we just took out a chunk saying that we have a Dirac delta in the middle of that. Well, what's that? Well, Dirac delta is just an infinite spike at the origin that has 0 width. Its area equals 1, though, exactly all the time. It's infinite, it's got 0 width, infinity times this 0 equals 1. These are these identity expression constants again. So this makes me happy, and I'm glad to see that. And when I wonder on my countenance upon thinking about that, it makes me happy, because I know that is so. So this is going to go a long ways to helping explain why then this goes in this turbulence theory about the Reynolds number, and he explains the limits of finite element analysis, and there are simply not enough steps in the cascade. Because, engineering works according to these principles of close enough and also not too far. So that makes me happy, and it's be something I can get into later. Dynamic light scattering. Yeah, so today's talk has largely just been kind of a recapitulation and an assertion of the requirements and desiderata of a theory that is the theory for truth, and here these usual notions and about what it needs for philosophy's sake to reestablish this Kant's sublime and Hegel's defense of teleology from what was then abandoned, that then to make it so that it's really easy to keep the whole ontological commitment to the ontology, but that's insufficient for this wider concern of the foundations. It's a suitable theory for a wide variety of logics, but don't get it wrong. The quantum mechanics is never wrong because people are always getting it wrong, and it's their fault, not its. Moment methods. says moment. Analyzing spectra via the distribution function method. So this is with distributions, and you can build distributions and functionals. These are some of the first places in statistics and probability theory was like, we do deal with not a real function that still has real analytical character. So yeah, I know that my Jordan measure here, or my Dirac delta, or my Heaviside step is kind of a bit outside your classical functional framework, but we're going to call it distributions or functionals, and we're going to say that they still have these particular properties, and of course that otherwise then it's just because all of these functions, area under them equals 1, and they're always non-negative. So we're keeping things simple in this kind of stuff. And then the analyzing spectra is the very notion of all this overtone and spectral overtone in the spectrum, the range of things vis-a-vis its distinct lines or notes. That is the whole idea of this discretization or quantization, or the indicators so arrived at vis-a-vis the range of them. The range. Range. Analyzing spectra via the distribution function method discussed above is practicable only if one has reason to believe a model distribution function gives a good representation of the molecular weight or size distribution function of a particular sample. In most cases, however, especially for solutions of biological molecules, the distribution of weights or sizes is unknown, or their momentum, or their charge interfaces, which result dynamics in their systems with regards to kinetics and kinematics, their size or their weight, their resistance to fitting, or their resistance to moving. Complementary concept, inverse, together must fulfill same. Window and square it in a box, look around from all sides. It would be particularly interesting to obtain from the sample a well-defined average, and to be able to estimate the dispersion about this average. These quantities, which are moments of the molecular size or weight distribution functions, can in certain cases be measured by studying either the homodyne or heterodyne correlation functions at small times. So when you hear dynes, that's like for the dynamometer or dynamics with respect to the dynamometer, and that it's used to measure the actual output of things vis-a-vis the linear things that go into and out of them, for an explanation of why they're empirical units in torque, and for the conversion of the rotational to the linear, and these kinds of things. And so we categorized heterodyne and homodyne with the inelastic and elastic, the adiabatic and diabatic, or rather adiabatic and non-adiabatic, with the entropy and entropy, and some of these other notions of the dynamic side and the static side of the spectral side and this linear and punctal side. Let's see here, a page came through. Consider the homodyne correlation function, which is proportional to the linear moment sub 1 q. So that'd be Heisenberg or comma t, the absolute value of that, or that squared, for a dilute system with negligible intramolecular interference. Then for a polydispersed system, that equals B after 8.4.2, after Pecora and Tagami, that this is from the section 8.11, effects of polydispersity on time correlation functions and spectra. Wow, so this is continuum mechanics which is to define how you can arrive at why quantum mechanics is never wrong. So 8.4, it has that Dubois and Violet and freely jointed chains have that. It is referenced there. So what it is from Pecora and Zim, Zimm, Zim, is that B equals k to the fourth E squared over epsilon squared R squared times this quantity, the n sub I dot n sub f quantity squared, for the molecular weight determination. Structure factor after the scattering per unit volume to determine molecular weights, the constant relating da da da. So this is in the molecular physics, and what's going on with that being in the resonance and waves theory, the higher order, and then bringing back that down. And it does mention Bessel. The Bessel function is called J. With regards to Bessel functions, usual consideration in systems of transformations in the Fourier-style and the Taylor-style analysis. So that's kind of what I recall that it was about. The central limit theorem and this uniformization limit theorem was about the Fourier-style analysis and the Taylor-style analysis together. In the oscillative and restitutive and the attenuative and dissipative in the power terms of the Taylor series and the geometric series and the orthogonal variation and cyclical character of the Fourier-style analysis with regards to models of attenuation and dissipation with regards to oscillation and restitution. So, and then that reminds of the discussion about the Eulerian and Gaussian and how important those are with respect to all such matters of the establishment of the behavior of these transforms that then are so built up that so much of the formulary is built up in these. And so trying to rehabilitate the formulary for the superclassical kind of has to be in terms of these. So when I look to G.M. Ogan's electromechanical effects and applications, which kind of is like, it was written about 50 years ago and today is being used to implement the latest, greatest quantum simulated quantum computers. That for these things about the mathematics and trying to figure out for analysis to be able to read the existing analysis and keep it in its own context and equip it and augment it with this fuller context, its implicits and explicits and its quantities and derivations and the openings of these perestroikas for the multiplicities so introduced, and to have in effect the decomposition or the structural deconstruction of the derivations for example, for complex analysis, for the reflections and rotations, for the analyticity, and for some of these other concepts that are so arrived from it in terms of the infinite series and these kinds of things, vis-a-vis the polar and the axon, all quite central, while at the same time that the origin is everywhere. That it does seem rather grandiose, but as well seems the general course that a thinking thing could do if it had arbitrarily much thinking that it could do, with the goal being that it results a message that it could relay with regards how to have the same original texts and to be able to both make their apologetics and their explanations of what they mean in any sort of the notion of there being a classical perspective or an application reflecting a linearization, bringing to a classical perspective, or this true centrifugal, or this extra classical, super classical perspective, for perspective and projection of the geometric sort. That is hoped, and one wonders that one be able to fulfill a sort of projection to all the existing corpus of analysis, this mathematics and its analysis, while equipping it with this context that it has, this non-standard analysis, super standard, in a great sort of way, disclosing its wider truths instead of coattailing the wallpapering, the fudge coating, the swept under the rug bit, or the fragmentation, the fragmentation into a billion languages, none alike, because there are a world of all sorts of derivations particular to their milieu, and they're proved out and they work. And so they have their stated and their unstated assumptions. So trying to sort out how that can all be kind of tractably made into a mechanical corpus and all pulled together is a goal for keeping theory from becoming a babble, and B, using the data, that all science has all this data, and to be able to not only use it to validate what it originally validated, but also to pull together what was gathered in a particular instant that will never come again, and to explain it in these higher order terms, which result these didactically more established terms. Well, anyways, that's the talk for today or so. I hope you have a great day, and that the weather is nice and the world is nice. And it's not always, but it is. So, hey, warm regards, and to your health. Thank you.